Hey guys, welcome back to Chem 1B. My name is Roane. Today we're going to be going over some kinetics and some more rate law stuff. This will be the last part of kinetics, so hopefully it'll be pretty simple. But to start it off, because we've already gone over some brief stuff about rate laws and rate orders and all that, we're just going to start with a type of a problem, a practice problem. So this is a problem I just pulled from the internet. This will look similar to a certain type of rate law problem you're given. You're going to have a table, okay? You're going to have concentration of reactant A, and reactant B, reactant B, sorry. And then the brackets are concentration, and then you'll have the rates of those reactions. Okay, so, and we have to figure out these coefficients down here. Okay, we have to figure out the x and the y. So in order to do this, we need to look at the different trials, because each trial, they're changing a concentration. Okay, each trial they're going to change a concentration. Maybe they'll keep one the same, maybe they'll change one, maybe they'll change both of them. You're not going to know. You'll just have to look at the table, and then you see how those changes in concentration affect the rate. Okay, so almost always trial number one is going to serve as sort of a base or like a reference. Okay, so trial one is the baseline where we're starting. Okay, we start at 0.2 for both. Okay, and that gives you a rate of 0.4 molar per minute. Okay, then from reaction 1 to reaction 2, we're changing the concentration of reactant B by 2. Okay, we're increasing our concentration by 2. This leads to an increase in the rate by a factor of 4. Okay, so we're increasing the concentration by a factor of 2, but we're increasing the rate by a factor of 4. Okay. Secondly, if we look at the difference between if we looked at the difference between reaction 2 and 3, we wouldn't be able to decipher any sort of differences. So if we look at the reaction from 2 and 3, right, we're going from 1.6 to 0.8. However, we're completely changing this one here. And we're completely changing these factors. We're going from 0.4 on B to 0.4 on A. And we can't do that. We want to compare it from the baseline, okay? So now we're going to compare reaction 1 and reaction 3. Okay, earlier we were comparing reaction 1 and reaction 2. But we want to compare all the new reactions with the baseline, usually. Okay, unless we have really long, complicated tables. But for these shorter tables, we want to be comparing our additional reactions or trials with our baseline reference. Okay, so comparing reaction 1 and comparing reaction 3, we see that there is an increase in reactant A now. Reactant A is increasing by a factor of 2. Okay, reactant A is increasing by a factor of 2. However, that only leads to an increase of times 2. Okay, so now we have all the bits of information we need. We double reaction B, we increase the rate by 4 times. We double reactant A, we increase the rate by 2. Okay, that's all we're going to need for this now. Okay, so now we can say that, okay, we increase the concentration of A by 2, we increase the rate by 2. Okay, that's a 1-to-1 proportion. We increase the concentration by 2, we increase reaction by 2. That's a 1-to-1 proportion. So this interval for A, okay, is going to be 1. Okay, the amount we increase our concentration by A is the amount our reaction rate is going to increase by. Okay, for B, we increase our concentration by 2, we get a rate increase by a factor of 4. Okay, that is going to show that B increases the rate by a factor of 2. Okay, and then we have K here, and rate. All right, so this is our rate law. Okay, K is going to be equal, or rate is equal to the rate constant K times concentration of A to the factor of 1 times the concentration of B to the factor of 2. Okay. So there's a couple more things we can do with this. Okay. Just in case you ever see a question that says, what's the rate with respect to the rate order with respect to A? Okay, that's this. This A has a rate order of 1. A has rate order 1. B has rate order 2. Okay. However, if I was going to look at the total rate order, okay, the total rate order of a reaction like this, total rate order for a reaction like this is going to be just, I messed up the exponent. Total rate order, you just add up all the exponents. Okay, so this is going to have a rate order of 3, so a total rate order 6 to 3. The whole reaction has a rate order of 3. You just add up all the exponents. And then the last thing I want to do is talk about the units of K. Okay, so the units of K, we talked about this before. The units of K is always going to be in molar to some exponent, and then with time to some exponent. Okay, so obviously we used minutes up there. Well, actually that exponent is always going to be -1. Okay, but we used minutes up there, so this is going to be minutes to the -1. And then we talked about this in the last video, but this exponent for molar, okay, x is always equal to the rate is always equal to, is always equal to 1 minus the rate number, or rate order number. Okay, so this is going to be x, and our rate order number is up here, so it's going to be 1 minus 3. So this is going to be x to the -2. Okay, so this is going to be m minus 2 minutes minus 1, and that is our units for K. So I hope this helped. If you want any additional practice, feel free to use our worksheet. And as always, drop by in office hours if you have any questions. But I wish you guys luck on all of your finals, and I hope you guys have a good quarter.